Well, hello everyone and welcome back to Adrian's Digital Basement. On today's video, it's another episode in the Commodore 64 Repair-a-thon series. We're going to be looking at machine number 3, which all I know about it is it says 3 green screen. So something's wrong with this thing. It might be simple, it might be complicated. If it's too simple and boring, I'll actually bust out the next machine in the series, number 4, to find maybe an interesting fix. To spice things up a little bit, I'm going to be repairing the machine with this, a Hantek handheld pen oscilloscope. I've done a couple videos on inexpensive Hantek scopes that are useful for repairing Commodore 64s if you don't want to go and spend hundreds of dollars on a bench type scope. Something like this might be right up your alley. I think this costs about $65, at least at the time I ordered it. So, without further ado, let's get to the repairing. All right, the third machine. Before I open this thing up, let's take a look at this Hantek scope a little bit. So the Hantek pen storage oscilloscope, I'm pretty sure I bought the 20 megahertz version, but it seems to come up to 250 megahertz. I find that extremely hard to believe. 96 megasample per second sampling, up to 1 gigasample per second, obviously for the fast one. USB interface and plug and play. And yes, of course, this does need a PC for operation. I have no idea if it's like Windows, Mac, Linux compatible. Obviously, it's going to work on Windows. Software support, Windows 2000 all the way through Windows 8. Wow, that was just like the last one I looked at, the USB one at least. And that one worked perfectly on Windows 11 or Windows 10 is what I tested it on. As far as other systems and compatibility, who knows? It's quite possible that there is aftermarket software to use this, just like there was on that original $60 scope I used, where the aftermarket or the open source software was far superior to Hantek's own software. We'll have to take a look to see if this is also compatible with that open source software, because if it is, that's actually great, because that open source software is actually what made that scope usable versus the Hantek software, which was kind of a joke. I'm just going to mention that I definitely paid for these with my own money. These are not sponsored videos or anything like that. So, of course, I will talk about the faults or whatever that these things have, if they have any, or the good points, the bad points, and everything in between. All right, so we have a little adapter here for something. We have the scope itself. Get this out of here. Oh, it's pretty lightweight, kind of nice. And the only thing left in here is this, which of course is a little clip. So this would go on there and will allow you to hook onto ICs and things like that. Alrighty, so you can think of this thing as a much more capable logic probe. The thing about logic probes is they're useful, but in a very limited sense. They can only really tell you if something is high, low, nothing, I suppose, like floating, or maybe it has data. It's usually like 4 things it can detect. This, on the other hand, from my understanding, is a full 20 megahertz oscilloscope that when you plug it into your computer via USB and use the original software, you have all the functionality of a regular oscilloscope, but in a very inexpensive and obviously extremely compact package. I can't say for sure what this little adapter is. It looks like this would plug into a regular BNC and that is some type of other connector. So unless, oh, I see. Okay, I think that goes onto the end there. So that would be like if you want to probe a BNC jack, this connects the ground to the ground ring there, and then the center conductor to the little probe tip there. And you wouldn't need to use this alligator clip. What else is there to report here? Well, there seems to be a battery compartment, so I'm going to take that cover off, and maybe it takes a 9-volt battery. It's got a rubberized texture on here, so it's quite grippy. And if I think about like the form factor of this, it's not too bad here. Like holding this, you can obviously push these buttons here. You can, not super easily, but you can obviously rotate this knob here. And yeah, I mean, it's not half bad. All right, what is behind door number 1 here? It's very tight, the screw. Maybe there's nothing through here. I mean, this has USB. Okay, that screw came out, but I don't know. There we go. Okay, so it's a battery compartment with no contacts. It looks like it takes 2 AAA batteries. So this must be the same case as used for maybe like a pocket multimeter or voltage probe or something, something, something. Like, is there a screen, an LCD screen here? That's probably what it is. We have an LCD screen, it would be there, batteries there, and then this would actually be a little handheld multimeter. With, you know, that's not really that bad of a form factor, I gotta say, for a multimeter. But yeah, interesting that clearly this is not used on the oscilloscope version. Incidentally, the screw is threaded insert, so it's not just into plastic. How nice is that? Okay, I'm gonna plug this into USB. Here in the device manager, we have an unknown device. Right. While it did come with this CD here, I'm not gonna even try this. I'm just gonna go right for downloading this software from the web. All right, here we are on the Hantek site. So there's a driver from 2021. So that implies like Windows 11 compatibility, but the software is from 2015. So it's probably gonna be kind of junky, just like the last one. All right, here are the drivers for the pen scope. A couple different ways you can do it. Of course, I could right click on INF and hit install, but let's do it the other way and say update driver, browse. We're gonna point to that directory and hit next, and that should do the trick. There it is, PSO2020, probably for 20 megahertz. Now, just for fun, I have loaded up the old Hantek software, the one that I was using, or is this the open source one? I can't remember. I think this is Hantek's own software. Is this actually working? I don't know. I don't think so. It doesn't seem to give an error, but we don't seem to be seeing any trace. Like the trace would be right there. We're not getting anything. So I don't think this software works. It's funny that it just runs without any errors, but you know, I guess it's old software. It's just not that well made. The open source software is called Open Hantek. Let's just give that one a try. And no, I'd say this does not work. It's definitely looking for the other external box type and not this pen scope. Okay, so here's the Hantek software. I've uncompressed it. Let's run setup. Put an icon right here on the desktop. So let's run that. Oh, it just clicked out of the scope itself. Oh, it looks very similar to the other software. So junky, but there it is. It is working. I've gone ahead and I grabbed the little portable Hantek, which I really like. I'm gonna stick this into the function generator output, which of course is gonna create a calibration signal that we'll be able to sense with this thing. So I just push that into here like so. And here we are on the software. How do I zoom out? Wow, you cannot use the scroll wheel. It's just, I'm very used to doing it that way, but there it is. It is working, 1 kilohertz. So that's good, and I don't know if there's like a probe compensation control on this. I'm noticing here it's kind of dim, but there's actually a flashing green LED in this end part. What exactly does this do? Nothing that I can tell. Oh wait, maybe this allows you to change the time base. Well, that would sure be nice if you could, but pushing these buttons doesn't seem to actually do anything on the software. So that looks like horizontal time base, vertical time base. Well, that actually works. Wait, that is actually changing it. So these buttons do actually work. Voltage, okay, that's changing the scale. I kind of dig that. And this one, oh, this actually zooms in and out. All right, handy, very handy. So I guess the one question is, why does this T with the arrows not seem to do anything? I don't know. Doesn't seem to do anything at all. If we go to this setting here, that does change the time base, and you can see the slider actually moving on the Windows interface, which I'm digging that. I'm really digging that. Okay, let's see what else. We got only have YT mode. Let's switch to a really slow sample, like 1 second. Is there a roll mode here? There doesn't appear to be any roll modes, so that's a bummer. Even though you can have a sample time of 5,000 seconds per division, there's no roll mode. That's not very useful. So anyways, you know, I didn't expect this thing to be amazing. I just figured we'd be able to see some signals and have a lot more usefulness than a logic probe. Okay, let's just see. Trigger mode has edge triggering, normal, single shot, and auto, so that's helpful. You can do positive and negative slope for the edge. You can drag the waveform around, and I can obviously move the trigger point up and down. Well, that's okay, I guess. Looks like we can turn this digital voltmeter off and on, and the frequency counter is there, so that's helpful. I wonder if this RS button, oh, that stops it. Oh, that stops and starts the capture. I see, that's interesting. I don't know what R and S means, but whatever. All right, back to the 64. So yeah, we can see it's in pretty good shape. It's definitely very yellow. I mean, the keys are yellow, case is yellow. Not a whole lot to report. Stuff floating around inside. Yeah, so let's crack it open. I am going to wager that someone has been in this machine before, and the reason why I say that is because there are little dimples in the plastic here where the screws have gone in, but maybe Commodore was really bad when they factory assembled these, and they often over-tighten the screws as well. One thing is there's definitely like a crack that happens when I loosen the screws, which is an indicator that, listen, yeah, that cracked. Indicator that these screws have been here for a very long time, potentially since this thing was new, or, you know, maybe 25 years ago, because of course this computer most likely came out, this particular one was probably made sometime in 1983-ish, I'm gonna guess. That's a good amount of time ago. Here we go. Oh yeah, you hear that cracking? That is normal. Look at this, it's got the shielding inside, it's kind of unmolested. I'm kind of thinking now that this thing hasn't ever been opened up. I don't know. Maybe, maybe not. I love how this has like little like hole punches here. Obviously like float around inside the machine. It's just ridiculous. All right, let me get the screws out. But while I do, let's just talk about this computer. So yeah, obviously we got the old regular old bread bin, the 250 407, I think it is. There's a sticker, or it's not a sticker, that's just one of the things. Yeah, 250 407. Lots of stuff in sockets. The 3 ROMs, that's really useful. If someone had owned this and wanted to go to Jiffy DOS, no soldering required to put a Jiffy DOS upgrade in here. So pretty sweet there. The processor, though, is on the motherboard permanently, as are the 2 I/O chips. But the SID and the PLA are in sockets as well, so that is easy for troubleshooting perspective. Now, I didn't just test this right now. We'll test this in a second again. But last time I tested this, like I said, just gave a solid green screen. I'm going to wager that, well, there could be lots of things causing that. I'm thinking that PLA, maybe the VIC-2, something simple, because solid green screen's not really like a normal behavior. There's a keyboard spring in here. That's what was floating around in there. That's interesting. There was no broken key on this particular computer, but these came all in a batch, all these together, and they probably were with other machines that did have broken keys. All right, let's get this out of there. Look at that. Blech, bye-bye. All right, let's get these little floaty bits off of there. This yellow color RF shield is there on the bottom, so I don't know if I've always seen this type with cutouts in it and mud or something there. Let's take a look at the bottom of the board for any kind of rework signs. I'm not seeing a thing. This thing is looking mint. A little bit of flux there, but that would have been from assembly. Everything here looks really good. This RF modulator is hand soldered, so there's always a bit of crap there. Totally unmolested, at least from a solder perspective. Let's check the date codes. So 15th week of 84, 7th week of 84, 1784, 1784, 1684, 1584, 1584. Now these RAM chips here are actually from 1983, 36th week 83, but we know these other solder chips are later. Here's 12th week 84. So I bet you it's sort of like batch assembled, where the machine was partially assembled at some point and then thrown in a bin because they didn't have all the chips they needed, and then they put the rest in. I mean, who knows? Commodore was doing all sorts of interesting stuff at that point. Let's take a peek under here, see what we have for the VIC-2 chip. Goop on there, but everything appears to be in good order though. All right, I think it's time for testing. So I got this ready, but let's get the video and the power hooked up and see what we see. All right, let's turn this on. I haven't tested my RetroTink setup. Maybe I should grab my other machine, but let's just see what happens here. Okay, look at that. That is not a green screen right there. That is a whole lot of cool garbage. You know, that would be like a demo intro with awesome graphics like that, all that like, I like it. I like it a lot. All right, for using the scope, I have a longer clip lead connected to this for ground. Whoops, well, that didn't stay on, did it? This is what I always do. It's not good for ground integrity, but I basically push the boots together so you can't accidentally short stuff with the ground lead. And then I take this hook lead here, hook it onto something like there, onto the shield around that, and that is a good long connection so I can now freely go around the whole board. Okay, so these boards are really well known for failing PLA. So this particular era, like in the 84, early 84, extremely unreliable PLAs. So let's go to the schematics here and let's zoom up here on this PLA that's U17, and let's take a look and see if we can look with the oscilloscope at the output lines, which is everything on the right side here, to see if we see anything that is stuck low all the time. That's a typical failure mode of these bad PLAs that are on these boards. Now it's in a socket, so I could easily just pop it out, pop a different one in, and we'd have a super quick fix. But you aren't always going to be so lucky with your 64. You might have one that's soldered in, so we want to be able to look at maybe what's wrong with this one just to identify for sure where the failure is. I'm kind of going blind here. I'm not quite sure what we're going to see, but let's take a look. All right, I'm going to jump to my 4-way screen thing. People seem to enjoy that on the last videos I made, so here we go. Let's see. I have the PLA down here. I have the oscilloscope up here. Let's see if I can get this all set up where we can see everything together. There we go. And put on my magnifying goggles because I can't really see very much. Let's power on the 64. All right, so the pin numbers here are really hard to read here. It looks like that's 10, 11, 12, 13, 15, 16, 17, and I assume 18 for CAS there. All right, so I can see right off the bat, this has a similar issue to the USB 2-channel scope I tested, that it has software-based triggering. And this software does a terrible job with it. So when you zoom in too much, you get really unpredictable results. It looks like at 2 microseconds, it's just not triggering properly, but at 5 microseconds, it triggers properly. I think it's gonna be good enough for me to tell like if we're getting good signal. So I'm on like pin 2 of this RAM chip here, and let's just see if I turn this off and on. Yeah, I mean, we can see that there's activity. It's not great. I wish I could zoom in a little bit more if I hit the plus button. Oops, the wrong way. It's kind of triggering there. You see the update rate is really sluggish though, compared to how it was before. And now it's really fast. So we're gonna stick to this 5 microseconds, which says it's running at 16 megahertz. And if I go any higher, now it says 48 megahertz. And yet for some reason, now the update rate is just terrible. And I am on a USB 3.0 port, but this device is not USB 3. So that wouldn't help anyways. I think this thing is just not great. All right, anyways, back to testing. Definitely, I think the way it's working here is good enough for us to kind of see what's going on. So let's go to the PLA. Okay, I'm on pin 10 on the PLA, and it looks like it's just high. So that's good. That means it's not selecting anything. And pin 10 is ROM H. So that would be like the cartridge port. Pin 11 is ROM low, also the cartridge port. Okay, so pin 12 is an I/O pin, and it seems to be stuck. You see that? That's a bad signal right there. That is not working. And I'm pretty sure that that alone is gonna cause this computer to not work. So you could see little bursts there. And what those little bursts are is that PLA should be high, and then it should be going to ground when you see those bursts, most likely. And I'm saying that this is wrong. Let's turn it off and on. And you see it just right away goes to like 1 volt basically. It's almost like 968 millivolts. You can see there on the digital voltmeter. So yeah, this PLA I'm gonna say is scrap. So let's just keep going though. So I am currently on the I/O pin 12. Let's look at pin 13, which is the GRW pin. Ooh, that doesn't look super good either. We're kind of low. Let's just fix this. That's okay from a TTL perspective. That counts as high. I think it should be higher. I think it should be more than 3.36. And the computer doesn't seem to be doing nearly anything anymore. I think it's very, very unhappy. Let's move to pin 15, which is character ROM. That's the character ROM select line. Okay, that seems to be okay-ish, 3.3, not great. We are now on the next one, which is the kernel ROM. Okay, that looks okay. Okay, next up we have the basic ROM, not looking great. And then CAS RAM is the next one, which I think is 18. Okay, there it is. Okay, and you know what? I looked at the digital multimeter, it's 2.7 volts. That's not really that accurate. If we had the measurement up, which I don't have room right now, it would be 1, 2, 3, a little over 3 volts, like at the V max, because that's what we really care. The V max, which is the top, and the V bottom or V low, or whatever, V min. Anyhow, it all goes back to the I/O pin 12, which is this one, which definitely should not be doing that. So let's take this PLA out, and I'm pretty sure that it's the problem. All right, let's use the chip lifter here to get this out. This is not a screwdriver for everyone who screams in the comment section that I'm using a screwdriver and I'm gonna damage the motherboard or whatever. This thing has a bent tip to it and it's not sharp because it is specifically designed for getting chips out of sockets like that. All right, I got my little box of PLAs. I hope there's some in here. Ah, here we go. We have the Platinum, we have the Plankton, and then of course we have the PLA Advanced, which is the most flexible of all because this one allows you to basically, with these dip switches, it doesn't say on here what it can do, but it can basically emulate pretty much everything. Let's make sure the power's off, and it is. Let's pop this baby in. Before we hook up the monitor, let's check out pin 12, which is this one right there. Here we go. Okay, cool. Notice that that line is no longer stuck up at like 1 volt or whatever it was. It is now acting normal. Did you see that with those little drops? That is correct. Now, could you have found this with a logic probe? Maybe. This thing, definitely more useful than a logic probe, definitely. All right, we're back on the HDMI capture. Let's turn this on. There we go, working system. Bad PLA, that's a rather boring fix because I mean, you know, you're like, oh, it's just a bad PLA. It's like a given on these 64s. The thing is, I wanted to be able to show that you can look and see sometimes, not always, that these PLAs are bad because, like I said, a typical failure mode is those outputs end up drifting down, 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 and down until, like you saw, the I/O one there was basically just at like 1 volt or less than a volt or whatever it was. So any device that was connected to that I/O line was just basically turned on all the time, which is why if you have like a 1983, 1984 machine like this, and it's not working, if you really don't know what you're doing and like the PLA is in a socket, you can go ahead and get a replacement PLA like Daniel's Gal PLA, which you can get all over eBay now really easily for a pretty inexpensive amount of money, and try swapping it out. Problem is, if this is soldered to the motherboard, you really want to be able to tell for sure that it's not working, and the oscilloscope can definitely give you that clue. Now, I have had PLAs before where the outputs all looked okay and yet still caused the computer to not work. What happens really, I think, is like you have all the inputs and then you have the outputs. And the way the PLA works is the combination of inputs results in a certain combination of outputs. Well, I think there's like a table. You can imagine a table of all like the lookup tables for all the ins and all the outs. And maybe that little array can get messed up where like certain areas of the table are damaged or don't work as they should. So essentially the outputs start misbehaving and going low when they shouldn't or going high when they shouldn't, stuff like that. So it can create bus conflicts really easily if you have like 2 chips being selected at the same time. And obviously, like I showed, with the output stuck at 0, that is definitely creating bus conflicts because you could say select the kernel ROM and the character ROM all the time if those lines are stuck at 0. So that's why looking with the oscilloscope at the PLA is just a good way to see if there's a problem. Let me grab a marker here and let's mark this one off here with a big X. So the machine appears to be working, like we have a basic screen. Let's get the diagnostic test harness next, and let's see if it actually passes the tests. So speaking of test harnesses, I have a new test harness, and it's one that a viewer sent in. And let me just grab all the parts out of here. So this was sent in by Mike, and it is Sven Petersen's new design, and I created like extra long cable so I can use it on a 128D. Basically, this adapter right here is for using it on a 128D. It's the keyboard adapter. And then it has all the regular connections here. So it's got like the cassette port, although it has a pass-through, which is interesting. The 2 controller ports. This is what connects to the keyboard. And now it has a ribbon cable. Before it was simply a loopback connector. So I'm not totally sure what has changed there. We have the IEC loopback, so that's the same as what I was using before. But essentially, this one no longer has the problem of the control ports always failing. I didn't throw away my old tester. I think what might have happened on it is one of the ribbon cables pulled out a little bit and maybe lost contact, or I had trouble with the ribbon cables on the last one, and I think that's why it was always thinking the control port was bad. Either that or like one of the ICs on the main user port board had gone bad. But either way, I've tested this one after I put it together, and it completely works perfectly. So thank you very much, Mike, for sending this in. Let's get this connected up to the machine here. Let's validate that it's working properly. Okay, we are ready to go. Let's turn this on. There it is. Looks good. It's clear. Okay, control ports tested good. There we go. Sound test is working. Oh, it's kind of noisy though. I'm not capturing direct audio capture, but there's a little bit of static in the noise. Okay, well, definitely it passed all its tests. So let me remove the diagnostic harness and let's switch over to my other cartridge. What am I thinking of? Easy Flash. So we can run some, you know what? We have the requisite test for any of these diagnostic sessions. But yeah, I love how long these cables are. I wasn't gonna mess around and have like cables that were too short for certain machines, because like the 128D, the keyboard connector, is all the way on the side. It's like as far as possible from the user port, along with the cassette ports also on the side of the machine. So you really need long cables if you want to make sure you test everything properly. All right, the Easy Flash 3, here we go. Let's get this in. Let's move that out of the way. I'm gonna need a joystick or something. Let's plug in the NES controller here. Okie dokie, what are we getting? There it is, looks good. I'm always plugged into the wrong port. Always, it's ridiculous. All right, down to Adrian's tools. 8-bit dance party, everyone. Let's listen. All right, let me turn the speaker down. All right, so that obviously is working. I don't hear any problems with the SID there. It's a little noisy, but that's just how some SIDs are. They just have a little bit of a buzz in the background and not too much you can do about that. Now, I know the fix on this machine, like with this bad PLA, was very simple, but it underscores my philosophy that I try to understand what is actually wrong with machines before I start removing chips. And I gotta say that this little oscilloscope thing here, which incidentally I just looked on AliExpress, costs a whopping $56.46 with $4.39 shipping to the US right now. So about $60 is pretty good. I mean, this is not as useful as the larger 2-channel version because there's 2 reasons. It's a 2-channel scope, the other one, that can be useful in certain circumstances, but also that open source software, Open Hantek, at least initially I didn't see it working with this. So that is a negative because that software really improves the capabilities of that other 2-channel scope. And if it can't work on this, then that's not so great. Maybe there's a version of Open Hantek that does work on this. I didn't actually do that much research into it. So if you do know that it works, please let me know in the description below and I'll pin your comment for anyone who's interested in buying this. I do like the controls that are right on this. That's a real advantage over any other oscilloscope that I've ever seen because you can very quickly switch like the time-based pause and start right on here while you're holding this thing, which is pretty useful. The flashing here, I guess that's more just to indicate, I take it, I don't know what that does. I just pushed the start button and it's still flashing. So it just means that it's running, I guess. Not too sure about that. But overall, I am pleased. This thing works. It's 60 bucks. It is infinitely better than a logic probe. So if you don't have a logic probe and you don't have anything else, this is not a bad purchase. It really isn't. Now I had this Hantek out earlier and I have to say, I am actually really pleased with this device. The interface is a bit hard to use and kind of infuriating sometimes, but I find myself using this quite a lot, like when I'm doing stuff off camera. And the reason why is because when you use the oscilloscope that requires you to look up at a screen or even at a standalone bench oscilloscope, you have to take your eyes off of the thing you're working on. And if you're like probing something that's very small and you look away, it can be easy for your finger or your hand to slip and like short something out. With this, I can just set this up on the bench, like right next to what I'm probing. And then that way, I'm not actually having to really move my eyes very far away from what I'm looking at. I can just look right at the screen here. Now this is of course twice as expensive as this. I kind of recall this was like 120 or 140 bucks or something. So it's a lot more expensive. But the fact that this is battery powered and portable means that it is extremely versatile. Anyways, yeah, I do really like this. I still recommend this. I think the OON version of this is a very similar price. It's also very good from what I've seen on reviews. I don't own one, so I couldn't say. But does this pen scope work? Well, yeah, it really does. It's got those same limitations as the other software USB one that Hantek makes, but if you got no scope, as you could see, we could very clearly see that that signal on the PLA was bad with this, and that is something that would just be pretty much impossible to do without some kind of oscilloscope, whether it be an analog one or a digital one like this, or a $5,000 one. So that's going to be it for this video. I know it was a short fix and it was an easy fix, but I wanted to show that you could see bad PLAs in action with something like this, and I think that is exactly what I accomplished. So if you like this video, thumbs up. I'll put links to buying this thing if you're interested in the description below. Check out the other 64 Repair videos if you haven't seen them. This is number 3 of 12, I think. So there'll be lots more in the future. I will be definitely trying to intersperse these repair videos with other repairs so people aren't like 64'd out all the time. In fact, there were several comments on the last video, people asking for Atari repairs, because I do have those broken Atari 8-bit machines as well that need some work, but got lots of other things to work on as well. And of course, on the second channel, there'll be mail calls and CRT related stuff and stuff like that. So yeah, if you liked this video, thumbs up. If you didn't, you know what to do. Subscribe really helps me out, especially on the second channel. I'm trying to grow that channel. Huge thanks to my patrons. Their names are scrolling up the side of the screen. It allows me to buy stuff like this for reviews on videos. And yeah, it's gonna be that. So stay healthy, stay safe. I will see you next time. Bye.